All right, let's just jump straight into it. We're going to tackle a challenge that, let's be honest, probably keeps a lot of you cloud architects up at night. And that's designing a bulletproof automated validation suite for your multi-cloud Kubernetes upgrades. Doesn't matter if you're on Amazon EKS, Azure AKS, or Google's GKE, this one's for you.
I mean, this is really what it feels like, isn't it? You click upgrade, and for a moment, it's just this white-knuckle experience. You're hoping, you're praying for a smooth flight, but there's always that little voice in the back of your head going, is this the one? Is this the one that's going to bring the whole system crashing down?
Well, today, we're going to trade in that hope for a rock-solid plan. This here is your blueprint. It's how you, as the architect, can build a system that turns that gut-wrenching uncertainty into just unwavering confidence. We're going to make sure every single upgrade you do is a safe flight. So first things first, let's call it what it is. The upgrade headache. Even something that looks like an innocent, minor version bump in Kubernetes can feel like you're performing open-heart surgery. Why? Because under the hood, you're basically rewiring the entire nervous system of your cluster.
And the potential for things to go wrong, man, it's lurking everywhere. One second, all your dashboards are green. The next, bam, the network is a mess and your services can't talk to each other. Or maybe your workloads just go dark, failing all their health checks. Even worse, your critical storage volumes suddenly refuse to attach, or a security policy you relied on has just vanished. These are the nightmares we're trying to avoid.
I love this analogy because it's so spot on. You can't just take the system offline, right? The business needs it running. So you are, quite literally, swapping out the engine of a plane while it's still in the air. The only way you can possibly pull that off is with a meticulous, automated checklist that verifies every single vital sign after you're done. In that checklist, well, that's what we're calling the automated safety net. This is the big pivot. This is where we stop firefighting and start fireproofing. It's all about architecting a system that gives you the power to upgrade with total confidence because it's backed by solid, automated proof that your cluster is healthy. So, what is this safety net really? It's an automated validation suite. Just think of it like a team of tireless little robotic inspectors that you unleash right after every upgrade. Their only job is to go in and rigorously test every single critical function, networking, storage, security, you name it, and make sure everything is running exactly the way it's supposed to.
Now, to build this suite, you need a solid foundation. You can't just test things randomly. So we're going to break it all down into what we'll call the 4 pillars of validation. These are the 4 non-negotiable, absolutely critical areas you have to test to give your cluster a clean bill of health.
Okay, let's start with the absolute bedrock of the entire cluster, networking. Because let's face it, if your network is down, you are dead in the water. Nothing else you test is even going to matter. Your validation suite has to be absolutely relentless here. It needs to ask, can pods actually talk to each other? Can they resolve internal service names and, just as importantly, external domains? Is your ingress controller correctly routing traffic in, and can your pods get traffic out? And maybe most importantly, is your CNI plugin, the container network interface that's the brains of the whole operation, is it functioning perfectly?
All right, so your services are talking. Fantastic. Next question, can they remember anything? And that brings us to our second pillar, storage.
An upgrade can easily throw a wrench into that delicate connection between Kubernetes and your cloud storage system. So you've got to ask, can we still spin up brand new persistent volumes on the fly? Can our stateful apps reconnect to the storage they already had and actually read their data? Are our storage classes still working? And for disaster recovery, can we successfully take a snapshot and restore from it? These are mission critical. So with network and storage locked down, it is time to focus on the star of the show, your applications. This is pillar number 3, workloads. And this isn't just about checking on one app. It's about stress testing the core of Kubernetes itself. You need to deploy a canary application. Does it come up healthy? Are the readiness probes firing like they should? Can you scale your deployments up and down without any issues? And can you perform a flawless rolling update and, if things go bad, a seamless rollback? These are the tests that mimic the real world. And now for our final pillar. This is the one that can be a silent killer: security policies. It's the area where one tiny oversight can lead to a massive, catastrophic breach. See, your apps might be running just fine, but an upgrade could have accidentally left a backdoor wide open. Your validation suite needs to be your watchdog.
Are your network policies still actually enforcing the rules? Are your pod security standards holding the line? Do your service accounts have the right RBAC permissions, that's role-based access control, and not one single permission more? And can your apps still get to their secrets securely? There is zero room for error here.
Okay, we've got our 4 pillars. Now it's time to get our hands dirty and actually put this blueprint into action in the real multi-cloud world. Because the core ideas are universal, but as you know, the devil is in the details, and those details are very provider-specific.
And this slide just nails it. The abstract goal, test dynamic persistent volume provisioning, it translates into very different, very specific actions for each cloud. On EKS, you're not just testing storage, you're testing the AWS EBS CSI driver with GP3 volumes. On AKS, it's all about the Azure Disk driver. And on GKE, it's the GCE PD driver. Your validation suite needs this level of specific detail for every single pillar across every cloud you run on.
So where do you start? Look, it's a simple 4-step action plan. First, you have to identify your mission-critical services and all their dependencies. Second, define your specific validation tests for each of those 4 pillars we talked about. Third, you got to automate the execution of those tests. And finally, number 4, integrate that whole automated suite right into your upgrade pipeline. Make it a mandatory, unbreakable part of your process. That is how you build a real culture of reliability.
And that brings us right back to where we started. Your next Kubernetes upgrade, it's already on the calendar. It's looming. The difference between that smooth flight and a fiery crash is the work you put in today. So the real question is, will you be ready? Will your automated safety net be there to catch you?